Hi, candidates. Very good afternoon, good evening to everyone, right? This side, Ankit Misra, and I hope everyone is doing well, right? So, guys, I'm already sharing my screen and I hope I'm audible and visible too, right? So, can you just confirm me once again? Anyone kindly let me know in the message box. Am I audible properly? Okay, Apeksha, very good, right? So, guys, we know that we have already completed multiple algorithms, right? Yesterday I was not well, so that was the reason I could not continue with the class. So let's just start tomorrow, today, and we are going to understand what exactly the proper requirement of different set of algorithms. And right now we are going to understand the bagging and boosting, and the first technique that we are going to understand is ensemble learning, right? So let's just start with what is ensemble learning. Before I just start this ensemble learning now, let me just briefly give you the overall recap what exactly that we have covered so far, right? So in the supervised learning, we know that we have already covered multiple algorithms. It was like linear regression, okay, and then followed by the logistic one, where we can use this logistic regression for binary as well as for multiple, like multi-class classification. Then we have completed the knife based problem as well, right? Where we can use this for linear, kind of regression problem and classification problem as well, right? And then we have also completed this decision tree, and we know that it was completely based upon the Gini index and the entropy concept, right? DCISI1 decision tree, right? And like your previous trainer has already completed this one, which is the k nearest neighbor. If you're not familiar with the k nearest neighbor, na, NEAREST, just let me know if you're not familiar with that one candidate, right? I'll generally try to repeat the same thing, right? If you're not getting the proper understanding of KNN, right? Now the problem is that we have we have multiple algorithms, but which algorithm we can use in different set of data set or different set of conditions, right? And the most important concept that we are going to understand, and this is again the interview point of view, important one, that is called ensemble learning, right? Ensemble learning is nothing. It's a concept. Let me just write this. It's a concept in ML where we use multi-model approach, right? It's like we use multi-model approach. We are where we are not just simply relying on the simple model or like a single model answer. Okay, so it's like if I have to predict the house price, I can predict the house price with the help of linear regression. If I have to predict whether the patient has the cancer, whether the given tumor is the cancerous tumor or not, we can predict it using the logistic regression or like decision trees as well, right? If I want to check the spam classification, I can use the knife based one, right? But in the every situation or every problem, I am just using the single set of model, right? But what about if I just want to check the answers from different set of models, right? I just want to do the same calculation over the linear one. If the problem is related to regression, if the problem is related to classification, I can use logistic regression as well, knife based as well, decision tree, KNN for the classification set of problem. So there is a term or like a terminology that is called ensemble learning. It's not the assemble one. It's like the ensemble learning. Inside the ensemble learning, we just have to use the multi-model approach. So ensemble learning are mainly divided into two parts. The first part is called the bagging technique, and the second part is called the boosting technique, right? Okay. Now, before directly understanding this bagging technique and boosting technique, let me just ask you the very basic question. Just open the paint first, right? Okay. So there might be some issue, right? Just guys, give me a second. I'm opening the paint, right? Okay. Now the problem is here, I just want to calculate the house price, right? So the objective is calculate or like predict the house price using ML. Okay. Now suppose instead of creating single model approach, I'm just using multi-model approach. Okay. So let me just take the first model that I have used is linear regression, right? Linear regression predicted the house price is 22 lakhs, right? It's close to 22 lakhs, right? Guys, I hope my screen is visible, right? There might be something issue related to the paint, right? It's not working properly. Okay, let me just rewrite this again. So the first model that I'm using is the linear regression, and let me just check this again. Is my screen is visible now? Just let me know, candidates, everyone. Okay. So the first model that I'm using is linear regression, and suppose it has predicted the house prices 22 lakhs, right? The second model again predicted the house price, but this time I'm using decision tree, right? Decision tree. And decision tree model predicted the house price as 23 lakhs, right? Then followed by the third model. The third model is like the KNN. Suppose KNN predicted the house model price is like 22.5 lakhs. Okay. I use the fourth model like the Bayes theorem. It's based on the Bayes theorem, but I can use it for like the classification problem, but it is generally recommended for the classification one, but right now I'm using it for the numerical part, right? So it's like the Bayes theorem. Inside the Bayes theorem, it just predicted the value as like some sort of 25 lakhs, right? And the fifth is like we have some sort of different types of linear regression. We can use that also, right? So guys, instead of just relying on the single model, I'm using 4 different models, right? Now, first model gives answer of 22 lakhs, followed by 23, third is 22.5, and fourth one is 25. Now, instead of completely relying on one single outcome, can I just say my final prediction is just nothing. It's like a averaging of all the prediction, or like averaging of all individual prediction. It's like 22 lakh plus 23 lakh plus 22.5 lakh and plus 25 lakh. If you can just solve this, you'll get the final answer. Let me just copy this first. Go to Google, simply write is equals to here and just apply the brackets and simply divide this by the 4. Now you'll get the average value. Now the average value that I'm getting is 23.125 lakh. So instead of just relying on single model, can I say the final answer I'm getting is 23.125, and now the final answer is something 23.125 lakh, and it's completely based on the 4 different models, right? So in the same way, candidate, we are using the technique. The technique is called ensemble technique, right? So in ensemble technique, the first technique you already know is called the bagging technique, and second technique is called the boosting technique. So all ensemble technique is like using the multi-model approach, but the multi-model should be the same one. Okay. So instead of using different model, now this time what I'll do, I'll just simply pick this data set. Suppose this is like my data set, and I have divided this data set into 4 different parts, right? Suppose the data set contains thousands of rows, and I have just reshuffled the data set and created multiple samples, right? The first sample, or like the first data set, second data set, third data set, and the 4th data set. All 4 data set are completely a sample of the given data set, right? Now I'll just simply create one model followed by each individual data set, right? And I'll just simply pick the one model, any of the model. It is like linear regression or like decision tree. Instead of calling the multiple model, I'll just simply create a bags of one model. Now suppose this time I'm just considering the linear regression model. So based on this data set, I'll create one model, and that one model give me any answer. I'll create another model, but it is based on the linear regression. The third, I'll create another model, but again, it should be based on linear regression. And the fourth model also, it is based on linear regression, right? Now, each model, I know that my data set is generally picked from the main data set. It's like all the sample data set picked from this main data set, right? And all this sample data set based on this individual data set, I have created a one individual model, and each model will predict some sort of values, right? And what I'll do at the end of this, I'll just summarize of all the values, or like take a minimum or like aggregated value, mean value of all the predicted value, and that all predicted value will be the final answer. Can I say this, candidate? Guys, are you getting my point? So in ensemble technique, we have 2 different techniques. The first technique is called the bagging technique. Let me just write this. And second technique is called the boosting technique. So in a bagging technique, what I'll just do, simply pick the data set. This is the data set. And you just simply divide this data set into different samples, right? And each sample, you will create a model. It's like I want to create a digital marketing post. So instead of just relying on single digital marketing executive, I am just saying I have a team of multiple digital marketing executive. I have just delegated the task to each individuals. Okay, you have to create a post, you have to create a post, and you have to create a post. And whatever post are like the more good one or like the best one, I'll just simply pick that post, right? That technique is called the bagging technique. So in this bagging technique, the processing that we are using is the parallel processing. What it say? It say we'll just create a parallelly model. This is model 1, this one is model 2, this one is model 3, and it can be up to n model, and each model will predict some values, and we just have to summarize, or we just have to take the mean or median value of the given individual outcomes, right? Like this way we are doing, right? It's like the final prediction is based on the individual or like averaging all the values. So this technique is called the bagging technique. I hope everyone is getting my point, candidate. Guys, just let me know, is there any doubt related to the bagging technique? Can I just summarize this? Inside a bagging technique, we have to create a bags of multiple model, and each model is like a product of the single model, right? Where we are using model 1 predicts something, model 2 again predicts some values, model 3 again predicts some values, and by getting all the individual value, we can take a average value, and that average value will be the final outcome of the bagging technique. Can I say this, candidate? Guys, just let me know if you're getting my point, right? What do you understand by bagging technique? This is again the interview point of view question. Candidate, just let me know. Everyone, just write down in the message box. Are you getting my point? What do you understand by bagging technique? Inside a bagging technique, we can just simply convert the or like create the multi-model approach where each model is responsible to predict some values, and after getting all the values, we'll create or like we just simply take an average value, and that is the final prediction of that model, and that technique is called the bagging technique. But we have two different types of technique. Now, the first one is bagging. What about the boosting one? Okay, so we have a formula for like a full form for bagging as well. The bagging generally represented by as a like aggregation, kind of aggregation. We are just aggregating the data. So it's like the bags of aggregating the data. Now, what about the boosting one? In the boosting technique, we are not using the parallelization. We are using the sequential technique. And let's just understand this, right? There is a candidate, and the name, let me just take the name of this candidate, Aman. I hope Aman should be not there, right? So like Aman was in their 12th class, okay? But due to some sort of like problem, it was like he was not able to clear the class. So somehow he failed, right? Now you know that he will try to learn more and more to just increase their IQ, so that in the next time they will pass the class, or they can attend like well score in their test exams, right? So it just try like he just try multiple methods, right? So in the first attempt, or like he's preparing for UPSC and some sort of exam, you can just take an example. In the first attempt, he has scored like 40%. Okay, he has scored 40%, but he know that if he learn well, if he train well, he will definitely increase the score. So again, he just identify his like whatever the mistakes, and just again appear for the second attempt, right? In the second attempt, he just eliminated all the mistakes that has been like particularly was the part of the first attempt, right? And in the second attempt, he has just increased more than the first attempt, and it was just close to the 60%, right? Now again he got to know he was not able to clear the exam, right? So again he will appear for the third attempt, right? In the third attempt, he was again trying to just reduce the like mistakes or eliminate the mistake that has been committed in the previous attempts, right? So in the third attempt, again he learned something new, and just able to achieve the score of 70%, right? Still he's not able to cross the 90%, so he will appear for the fourth attempt, right? In the fourth attempt, he just again trained and learn from the past mistakes, and then achieve the score of some sort of 80%. Then followed by the fifth attempt. In the fifth attempt, somehow he achieved the 90%, and then in the last step, or like the sixth step, he close to like 97 or like more than 97%, and this is a good accuracy. So guys, here you can see that Aman is learning on a gradual basis. It's like the first attempt was a weak learner. Aman was very a weak learner, right? In their first attempt. But he just identify the mistakes and pass their mistake to the second attempt, so that in the second attempt he will not repeat the same mistake, right? He just calculated the things, right? So the second attempt, Aman was quite more like engaging, or like some sort of knowledgeable person than the first attempt, right? So it is more than weak learner, you can just simply say. Now he will try to continue the same thing now in the last attempt, because he has scored the 97%. So I can just simply say this as a strong learner, right? So in the boosting algorithm, what we just try to do, we just try to simply aggregate the thing, right? And we just try to boost the things, right? So we simply pick a data. This is the original data set. In this data set, we try to create a sample. Now, based on the sample, we'll create a first model, and the first model is not able to attend well. So the first model, we generally refer this first model as a weak learner, right? Now, whatever the mistakes that has been done by the weak learner or like the first learner, all the mistakes will be transferred to the next iteration, right? In the next iteration, again, we will create an additional model like the second model. Now, second model will try to identify, okay, what was the mistake that was done by the first model? Let's just eliminate all those mistakes, and now let's just predict the value. But you know that in the second attempt, there might be chances that they will not get the perfect accuracy. So there will be some sort of errors, right? So all the errors or like all the mistakes will be transferred to the third iteration. In the third iteration, again, we'll create a model, and each model will try to bootstrap. Each model will try to bootstrap the next model. That is the reason we are saying this model as a boosting model. It's like where the previous model tried to boost the another or like the next model. And that is called bootstrap aggregation kind of. We are aggregating the thing, but we are like boosting the things as well. So the final learner will be the strong learner, and the first learner will be will be considered as a weak learner, right? So in the boosting concept class, we'll try to create the first weak learner model, and that weak learner will eventually turn out to the strong learner model. And after getting the strong learner, we'll get the final answer that will be predicted by the strong learner, because it has learned from their past mistakes multiple times. So that is the reason it will definitely predict some sort of like accurate value. And why we are saying this as a sequential method? Because all these models are connected in a sequence way, right? This model will not be trained if their previous model is not trained well, right? Same with this one, right? If this not trained well because of this model, right? So candidate, the bagging concept, we'll just create the bags of multiple model, and each will run parallelly iteration. It's like running multiple computers to predict the individual value. And in the boosting stage, it's like the class concept, where first we'll pass out the first class, then followed by the second class, then third one, fourth one, and 12th one, and then you can prepare for the UPSC or any civil services examination, right? So in the boosting concept, candidate, it is completely based on sequential concept, and the bagging concept, it is completely based on the parallelization, right? And all both technique is a term of this ensemble technique. I hope everyone is getting my point, right? Guys, just let me know, what is the difference between bagging technique and a boosting technique? Guys, this is the interview point of view question, right? Let me just go to chat GPT, and you can just simply identify the difference. In the bagging technique, we'll create the bags of multi-models, right? Where each model is responsible for their individual prediction. And after that, then we'll get the final value, right? Okay. Now let me just show you another example of bagging technique, right? The actual implementation of bagging technique is called the random forest model, right? Inside the random forest model, we'll create or we'll consider the multiple models, right? And let's just take this example. Where's the example? This one, right? Okay. Take this image. Now, this is the data set. Okay. What I'll do, I'll just simply pick one fruit from this one, the given instances. Okay. And now we have three different models. Okay. If I pass any one fruit to model one, it will try to say the predicted fruit is apple. Okay. I'll give the same fruit to the model 2. It will say the predicted value or like the predicted fruit is apple. Okay. I'll again pass the same fruit to the third, sorry, to the third model or like the third instance. Again, it will predict the value, but not the apple. This time it has predicted this as a banana. Now, what you are just getting candidate, the model one predicted, we are using the multi-model approach, right? The model one predicted this is apple. The second one, again, this is an apple. And the third one is like the banana. Now, what is the majority? The majority is going towards the apple. So it will calculate the majority voting and it will give you the final prediction as the apple one. Why? Because we are getting the majority voting towards the apple, right? So that is the kind of forest model, right? So random forest is just the example of the bagging technique, right? In the bagging technique, just you can just rotate this image, right? We'll create model 1, model 2, model 3, and each model will predict some sort of like their values. And after that, we can take an average of this value if we are getting the numerical answer. If we're getting the numerical answer, so we can take an average of the final prediction, right? And that will be the final prediction. But if we're getting the problem related to the classification one, so we will take the majority voting. Like the first model say it is an apple, second it is an apple, and the third one is banana. And what is the majority? The majority is towards an apple. So we'll finally predict this is an apple, right? So candidate, this is the concept of the ensemble learning. I hope everyone is getting my point. And let me just go to this chat GPT. And what is ensemble learning? I hope everyone will understand this, right? What is ensemble learning in ML? So ensemble learning is a concept, is a technique where we are using the multi-model. And multi-model, the first learner is called the base learner or like the weak learner, where I was giving this example, like the weak learner one, right? The first attempt was the weak learner. Okay. Now it is generally divided into two parts. The first one is called the bagging part. Yes. The bagging part is called the bootstrap aggregation. We are just aggregating the things. And the second is called the boosting part, right? Where the models are trained sequentially. And in the bagging technique where the model are trained independently and you can predict the value by averaging the value or like majority of the voting. If it is related to the classification one, and same you can give the final prediction with weighted combine all the models result. So ensemble learning generally classify into two parts. The first one is called the bagging technique. The full form is like the bootstrap aggregation. We are just bootstrapping and aggregating the things, right? Where we are learning the things from the past mistake, right? And the boosting, we are training the model on a sequential databases, right? We have a multiple example in the boosting technique and in the bagging technique, right? But we have to start first with the bagging one. I hope everyone is getting my point, guys. Interview will generally ask the difference between the bagging technique and the boosting technique. And they will ask the question related to the ensemble one. I hope everyone is getting my point. What is ensemble learning, right? Ensemble learning is a technique in the ML where we just simply create the weak learners or like the base model, and all base model turn out to the strong model, and it will parallelly or sequentially run the iteration to predict the values. And after the each iteration or like boosting, we'll just try to simply aggregate the value, or we can take majority of the like voting as well, right? So now let's just understand how to implement this bagging technique and then the boosting technique also. Okay. So in the bagging technique, we know that we have to create a bags of multi-model, right? So let's just start with the bagging technique. Sorry. Bagging technique. Here we will create bags of multi-model, and random forest is an example of this one, right? Now we have already covered one model that is called decision tree model. Inside the decision tree, you already knew that we have to create the tree structure, right? Decision tree, it will identify the root node, then followed by the decision node, and then finally the like the leaf node, right? And leaf node is just the final answer, right? Where the player can play the tennis or like some sort of answer like this, right? Now, suppose if you are just planting multiple trees, if you're planting multiple trees, it will eventually turn out into forest, right? planting multiple trees is equals to forest, right? And in the same technique, we have another model, and that model is called the random forest. Okay. Now, random forest is very simple model because it is collection of multiple trees. It is a collection of multiple decision trees model. In the decision trees model, we are just only using one decision tree. But if we are using multiple decision tree parallelly, so that model definitely converted into the random forest model. I hope everyone is getting my point. And we know that since we already completed the mathematics behind the decision tree or like the Gini index, so the Gini index will be same represented in the random forest as well, right? So what is random forest model candidate? A random forest model is same as the decision tree model if we are using the decision tree n times. If we are using decision tree one time, it is a decision tree model. But if we are using decision tree multiple times, it will become the random forest model. So I hope everyone is getting my point, candidate. Is there any doubt? What is the difference between decision tree model and like the random forest model? Guys, let me know in the message area. What is the difference between the random forest model and the decision tree model? So random forest model is just nothing, a collection of multiple decision tree. And that is the reason you are seeing the same example here, right? We are creating multiple trees. The tree one is called the decision tree one model. Tree two is like the decision tree two model. Tree three is like the decision tree three model, where each model is responsible for their individual prediction, prediction one, prediction two, and prediction three. And then finally, we'll take the majority of the voting, and then we'll give the final prediction of that model using the random forest. So whenever anyone asks you about how to apply the bagging technique, so you can just say random forest is an example of the bagging technique, and you can simply use the random forest to just simply mimic the bagging technique concept, right? Or to implement the bagging technique. Okay. Now let's just understand how to import this. And we are just using this concept on a very popular data set, and we have this data set that is called Wine Dataset, right? Now we'll try to understand the boosting technique in the next class. Okay, so let's just import the all modules, load modules, and I'll just take a reference, right? I don't want to like particularly write all the code from scratch. Let me just take a copy of this. Decision tree model one. Okay, yes, just simply copy this, load important modules. Okay, import pandas, PD, matplotlib, everyone is already familiar with that, right? So this is all about how to import module. Now, if you want to how to import like sklearn, using the sklearn, how to import random forest. So as from sklearn, you can just write out this thing from sklearn dot ensemble, because this random forest is a part of this ensemble learning. So you have to write this from sklearn import from sklearn dot ensemble import random forest classifier, or like random forest regressor. You can use it for both, right? Now this time we have a project objective, and the objective is some sort of like this. We have to predict a wine quality. Okay, there is a company where the wines are produced based on their features. We have to predict the wine quality. We have three different set of quality. The first quality is low quality. Okay, the second quality is called the medium quality, and the third quality is called the high quality, right? We have to, based on their wine features, we have to just ensure whether the given wine feature belongs to low quality, medium quality, or like a high quality. We have to create that model, right? So let's just call the data set as well, right? So from sklearn, we'll get the data set inside sklearn also. From sklearn dot datasets import load, and once you click on this load, you will get the data set is like load wine, right? This is the wine data set. And you know that you can simply go to this, write this wine here, wine word here. You can just call this load wine, and inside this wine, because this is a dictionary, so you can just write all the keys, right? And we have already performed this thing multiple times, keys, right? you'll get the multiple keys. And if you want to just call the data, so you can just simply say, okay, go to this wine variable, call out the data, and this is the like data in a array form. If you want to turn out into this data frame, so just simply write down this thing, data pd.data frame, pass this wine data. And because you know that we have to give the column names as well, so let me just give the column name as, inside this wine dictionary, we have this column name as like the feature name. So you can just simply say, go to this wine and just simply give the feature name. The feature names will give you all the columns name, right? And just simply run this code pd.data frame, and you will get the complete data frame. It's like we have some sort of multiple features of wine, like alcohol, malic acid, ash, alkalinity, magnesium, total phenols, and so on, right? Proline. All these are some sort of chemical combination, like chemical composition of the wines, right? You can just simply store this data set inside data frame. And now just go to this data frame and let's just create another variable. And the variable is like the target, right? So you can just simply call this as the target, and just go to this wine and call this values as the target. Now, if you run this data frame, you will get the final column as target as well. And we know that we have three different set of target. The first one is the 0, 1, second one is 1, and the third one is 2, right? Candidate, these are the target that we are getting, 0, 1, and 2. Now you know that 0 belongs to low quality of wine, right? 1 belongs to medium quality of wine, and 2 belongs to high quality of wine, right? Now we have to create a model with the help of random forest. And with the random forest, that model should be able to identify or like the classifier based on the features, what should be the quality of the given wine, right? Now, since we have already created this data frame, let me just call the sample. We don't want simply just perform the EDA, right? You already aware with the EDA part, right? So what I'll do, I'll just try to plot the graph. Let's just turn out this data into the meaningful visual. So you know that already. For I in range, you can just call out all the data frame, and inside the data frame, let me just simply write this as plt dot title inside f string analysis by, and you can just call this column. Simply run this plt dot hist plot or like histogram, and inside this histogram you can just call this df of I. You can give a color as blue, right? And let me just show this as plt dot show. You are already aware with that how to just particularly show the histogram for different features, right? We have different features, right? If you want to give hatching as well, you can do the experimentation part with this one, right? All these are analysis for the features one and the target one also, right? Now we know that because this data set we have, so let's just perform the correlation, and the correlation should be mainly for the features to the target, right? So let's just call the features. We know that all these are the features and the final one is the target, right? So we have to call this column alcohol to alcohol correlation, malic acid to some sort of like this. So what you will do, you will just simply call this one index and the target one like this one, last column. So let me just call this, copy the same code, use the ilog concept, go to ilog. What I want all the rows and just my last column. The last column is like the target column. So the correlation of the target one with the alcohol is like negative 33%, right? We have all the set of values, some sort of like negative 85%, and with positive 29, like 27 or like the 50% as well. Just to ignore this target to target, we'll get the 100% correlation because this is the same to same variable correlation, right? You can turn out this data frame into the heat map as well, right? Now we know that these are the very basic EDA that we are performing. You have to like perform all the EDAs. Let's just simply do the pair plot. Pair plot will try to plot all the pairs, and inside this hue, I'll just simply use the target to simply convert my visuals into 0, 1, 2. And we know that the 0, 1, 2 are like some sort of low quality of wine, high quality of wine, like medium quality of wine, and the high quality of wine. So I'll get three different channels. The first is for 0, second is for 1, and third is for 2, right? Since we are already aware with this pair plot now, so it will take time because the data set is very huge, right? And now let's just like proceed for the model building, right? Whatever the time it's taking. Model building, and inside the model building, everyone know you key. We have to call the dataset and turn out into the dataset into train test split. So let's just call the train test split from sklearn dot model selection import train test split, right? Okay. Now this is the like overall correlation. The correlation with the alcohol to the proline, correlation of the malic acid to the proline, correlation of ash to the proline, right? Same as it is magnesium, phenyls, and so on. And why we are getting three different colors candidate? Because we have three different qualities of wine. The first one is 0, 1, 2. Low quality wine, medium quality wine, and the high quality wine. That is the reason we are getting this all three different set of scatters, right? Now let's just, we have already called our model random forest using the ensemble technique. We have already imported the train test split. Now let's just convert the data into the train like X and Y part. We know that go to this data frame, call all the rows, call up to -1. This is like your X data set, right? Let's just call the sample. You have to ignore the last column. This is your X data set. And the rest step you already know candidate, right? df.ilog. Why we are repeating the things? So that you can easily understand, right? Y.sample, you can see series don't have, let me just run this. Okay, yeah, this is the time sample that we are getting, right? So now call this train test split and let's just convert this data set into training and testing part. X train, X underscore test, Y underscore train, and Y underscore test, right? Use the train test split technique, and you have to just simply give the X and Y, then followed by the random state. I hope everyone is aware with that, right? You can give the test size as well. The test size is some sort of like 20%. Perfect. Now, once you run this, you'll get your data set divided into 4 different parts, the training testing part, right? Now, we have to call the model, and we know that we are using the bagging technique, okay? So inside the bagging technique, we have to call the model now. So model is equals to random forest classifier. Why we are using the classifier candidate? The classifier is like the problem is related to the multi-class classification. Since it is multi-class classification, so we are using random forest classifier. Perfect candidate, right? Now just do one thing. Because we know that the random forest is like just the combination of multiple tree 1, tree 2, tree 3. So in this particular set of random forest classifier, we get one documentation that is called an estimator. An estimator is nothing, just a number of tree selection. The by default tree selection is 100. It says that instead of using one decision tree, we are using 100 of decision tree. So let me just write this. An estimator 100 means 100 decision tree inside bags. So we are using 100 decision tree to predict the final outcome based on majority, right? Based on voting technique. You can just simply write this as based on voting technique, right? Now we have already created the variable as model. So you know that if you want to train your model, so you have to give the X train and then followed by the Y train data set. Once you give this, you have created your random forest model. Now let's just try to predict the value. Model.predict, and you know that you have to give the X test value. This will give you the Y predicted, and you can just simply print the Y predicted because the model class is like 0, 1, 2. So we are getting some values are like for 0 class, low quality wine, high quality wine, and medium quality wine. Now let's just simply check the Y actual value. Y actual value was my Y test, and the predicted value was like Y pred. So you can just show this inside in the form of values as well. Now let's just try to calculate the score, because we know that we have created a model and we have predicted the values as well, right? We have different types of scores. The first one is called the training score, right? Inside the training score, you can just simply call your model and you just call the score and just simply give the train part of X and the train part of Y. Once you run this, you are getting the 100% of score as a training score. Now let's just calculate the testing score. So it's not always you will get the 100% of score candidate, because the data set is clean. That is the reason we are getting this as a 100% of score. Let's just give the Y test, X test, and Y test, and then we'll get the testing score. Why we are getting the 100%? Because the data is clean. Now let's just try it with the different decision tree. Instead of 100, let's just pick the 10 decision tree, right? So I am just changing the value of 100 to 10. Now again I have created the model. Again I'll predict the values. This one is the y test value. Now the training score remains 100, but the testing score is like 97. Now if I just change this n estimator from 10 to 1, it will eventually convert it to the decision tree, because a one random forest is like one decision tree, and one decision tree is similar to the decision tree. And here you can see that candidate, we are getting the training score as the 96% and the testing score as the 86%. So let's just increase the number of trees, right? Instead of one, let's just make it two, and we are getting the training accuracy as 90 and then followed by the 91. So you have to try it, hit and try, right? So you can just have to identify the best possible values. The by default value is like the 100 of trees, right? So we are getting 100% accuracy on 20 trees. So why should we use like why we have to use 100 number of trees to just particularly give or like rely on the majority of the voting. So it is recommended to use the number of trees, right? So that you can particularly get the highest majority voting, right? That is the reason we are getting 100 number of trees. You can make it to 200 as well or 500 as well, right? It's completely based upon the hyperparameter tuning, right? So in this way, candidate, we can convert the model into the proper score, or we can identify the predictions as well, right? Now we know that because this is a part of multi-class classification, so we have to calculate the precision score, recall score, F1 score, and accuracy score. Everyone know that, right? So now simply instead of calling each and every score, everyone is already aware with that. So let's just simply call the confusion matrix and the classification report. So go to this sklearn.matrices, import the confusion matrix and the classification report, right? Like this one. Now you know that how to create the confusion matrix. For that, you need to give the y test and then followed by the y spread. It will give you the confusion matrix. You have to just like focus on the diagonal part. All these diagonal part are the true positive and the true negative value. If you are getting any of the values apart from this diagonal one, it's like the false positive and the false negative area candidate, right? Guys, are you getting my point now? Candidates, everyone just let me know in the message area. Class, all the candidates. I hope everyone is getting my points. Just write down in the message area. Is there anyone? Okay. So in this way, candidate, you can simply create your model. You can just calculate the confusion matrix as well. Now, let's just finally calculate the or print the classification report. The classification report also takes the same argument. Simply paste the argument here. You have to pass inside the print function. And because the model is trained well and the test is well, so that is the reason we are getting every score like precision, recall, F1 score as a 100% of the accuracy. Now we know that based on set of parameters, we can change the value. Now let's just again make this to 1 to get the changes that we are getting inside the confusion matrix and the classification report. And here you can see that the 0 class is perfectly predicted. There is some sort of confusion with the the first class and followed by the second class, right? That is the reason we are getting some sort of misclassification. And this 3 is nothing, it's a misclassification, right? And how to particularly eliminate this? You can just increase the number of trees, right? Now let's just make this as 10 and let's just check the score. There might be some sort of a score like 97. So there is one sort of miscalculation. Let's just continue with that one, right? So that you can understand the final prediction cannot be the 100% accurate, right? So candidate, in this way, we can create a random forest model. And we know that, let me just revise this, random forest model, we can use it for both regression problem and for classification problem as well. Let me just write this. Random forest can be used in both regression as well as classification problem. Okay. And since it can be used in both regression and classification problems, so you can simply use it for like simple linear regression as well, multiple linear regression. Okay. You can use it for the binary classification and you can use it for multi-class classification as well, right? Multi-class classification. Perfect. So this makes this random forest a good model. And if you're working with the practical or like industry data set, so you can simply use this model to predict the problem if it is related to the classification one or like the regression one, because this model is completely based upon the decision tree. So before using this random forest, you have to be make sure what output that you are getting just only with the decision tree model, right? So this technique is called the candidate bagging technique. Now let's just start with the boosting technique. Guys, just let me know in the message area. I hope everyone is getting the point now. Is there anyone that like facing any doubt or some sort of issues or like problem with the concept that I am particularly teaching right now? Just let me know. Are you getting my point? What is a random forest? It's a technique that generally be used in the ensemble learning. Ensemble learning divided into two parts: the bagging technique and the boosting technique. Inside the bagging technique, we'll create the parallelization of the model, where each model will predict their individual value, and after that either we can take an average or we can take an like overall majority voting, right? This is called the bagging technique. In the boosting technique, we have to create a first weak learner. The weak learner, all the mistakes of the weak learner will be transferred to the second learner, and that it will try to eliminate all the mistakes, and then the mistakes will eventually turn out to the third learner, and then it will again try to eliminate the mistake, and then so and so on, right? And the finally you will get the strong learner. So this is the sequential method where weak learner directly converted into the strong learner. Each will give their prediction, but the weights are adjusted. The final values will be predicted mostly, right? So decision tree is a very basic model that you will use in the bagging technique, and to make it multiple bags of a decision tree, you can use the random forest model, and you can use the random forest model for both regression problem and the classification problem. I hope everyone is getting my point, candidate. So the steps are like: first, load the modules, do some analysis, do some data cleaning, do some pre-processing, right? Understand the visuals, do proper analysis related to your data set. Once you are good to go with the data set, then you can start the model building, where you need to convert the data set into X and Y part, right? If you're getting any missing values, now you have to fill out all those missing values, right? Because in the ML, you cannot use the missing values, right? Now, guys, I have one homework for you, all of you, candidate, because we have completed multiple models, right? We have used linear regression, okay, logistic regression, naive based, decision tree, KNN, decision tree, and the random forest. Okay, so I have two data set, and all these are the homework you have to try. The first data set is called auto MPG prediction. Auto MPG prediction. It's like miles per gallon prediction. You have to predict the fuel efficiency. Okay, what about like what is the project is all about? So the project one, create a ML model that predict the fuel efficiency. Okay, that predicts the fuel efficiency, and fuel efficiency is like the miles per gallon, right? Miles per gallon. It's some sort of similar like the mileage, right? You have to check the mileage efficiency, right? The project two is create a ML model that predicts the heart disease. Okay, heart disease prediction, and this is again very popular UCI dataset, right? Let me just go to this. You can just go to Google and write down this thing, auto MPG dataset Kaggle, right? Once you click on this, you can just click on this download, and you know that how to just use the dataset. You can just simply write down this thing, project one, paste the code, run this code, you will get the path, right? Since you know that you have to extract the data with the help of this path, So you have to use this OS module. Inside this OS, you have this list dir where you have to give the path. The path generally contains the file. Simply call the file and give the file as the file name, and file name is equals to some sort of like this, and the final path is like file path is equals to previous path plus previous path plus followed by the forward plus and then followed by the file name, right? And you can just simply call the pd.read underscore csv and give the file path, right? And you can store this data set inside AutoDF, right? Inside this AutoDF. And let me just run this. Why I'm doing this? So that you can directly start with the rest portion or like the model building, right? Now, one thing that you need to discover, this is the Y target value, right? You have to predict this one, and all these are the X features, okay? The problem is that you are not allowed to use the car name, right? You cannot use the car name. So what you have to do, you have to drop the car name, right? So let's just drop the car name. This is your task candidate. Drop this column and then build the model, right? And there is a problem in this one column. In any of this column, you are getting some sort of one textual data that is called question mark. You have to replace this question mark to np.nan. Nan is like the not a numeric number, right? You are turning this question mark to the missing values. And once you convert this np dot like question mark to np.nan, then again you have to replace this np.nan to their mean value, whatever the column that it has this question mark. Now you have to convert this np.nan to mean value, right? This is the problem that you will generally get inside this data set, right? Now then you can probably build your model, just do some analysis or like some sort of visualization and then create the model, because this is the numerical outcome that you are getting. So the problem is related to the regression problem, okay? So you are not allowed to use any of the classification part. Whatever the model that you are using, either naive Bayes, KNN, decision tree or random forest, you cannot use this one logistic regression because this is for the classification problem, not allowed, right? And there might be chances this also will not be allowed, right? So you have to check linear regression, KNN, decision tree, and then the random forest. Okay. Now again, go with the flow and then start with the project 2, right? I hope everyone is getting my point, candidate, because we have completed multiple lectures and now you can build the model based on the data set, right? That is the reason I am giving you the task, right? So go to the Kaggle and just simply write this as a heart disease data set Kaggle. Kaggle is a very popular like platform where you can get the data set for the AI, ML, deep learning, generative and all, right? Again, you have to copy this one, follow the same step, like this one. Again, this is your task, right? I'm just simply pasting the code here so that you can take a reference of this one, right? Now, again, use the same approach. Let me just do this. Instead of this auto DF now, I'll just simply convert this into the hard DF, right? It's like a hard DF and everything will remain same, right? So you will get the hard data set like this. Age, sex, CP is like the chest pain, test BPS, cholesterol, FBS. If you are not understanding any of the features, you can take a help from the chat GPT to understand any of the features, right? And the target value, 0 is like the no heart disease and 1 is like the heart disease sign, kind of something, right? So you have to create a model based on the first project was like the auto MPG calculation or like the prediction, and second project is to predict the heart disease, right? Heart disease based on patient features, okay? Whether the patient will so there might be chances to get the heart disease or not, right? You have to predict you have to build the model that can predict the same one, right? So heart disease based on the patient features, right? Like this one, okay? So these are the tasks that I hope everyone is aware with that, right? How to create the model. Guys, let me know if you are good to go with that one. Candidates, all the students right now, that those who are connecting, I hope everyone is getting my point, right? Is there any doubt related to any of the projects, right? If it is no, okay. Now let's just continue with the rest part, right? We have already created the model, right? A random forest model that it can understand whether the given quality of the wine is like belongs to low quality of wine, medium, and the high one. So we have already created a model now, but now we have to understand how user can predict the values now. So we have to create the prediction function as well. Okay, so let's just create the function. This is the final step for the today. Predict wine quality. Okay, predict wine quality, and just simply predict wine. Inside this predict wine quality, I'll just simply run a for loop over the X function, like X data set, that whatever I have, right? So let me just run the for loop for I in X, because I want to run the for loop, right? Guys, give me a second. Because we have the features stored inside this X now. So I'm running for loop over this X, and each I is like my features that we have to take from the users. Okay. Now, instead of this I, now you can just call this as column, because each is a column, right? COLUMN. Okay. Now, whatever the column that we are getting, you have to get the minimum value and the maximum value of that column, right? So minimum value is equals to go to the data frame X, call that column, and write this min. You'll get the minimum value. Copy this code, paste here. Instead of min, let's just call the maximum value, so that user can get the range, right? From where to where we have to give the value, right? Now you have to declare a variable where we are getting the input from the user. The input prompt is like enter value of I is like replaced by the column. So the first column will be like whatever the column. Let me just call the column, right? So that you can understand, right? X dot columns. These are the columns, right? So alcohol. So the first question will be like, the first argument is like input, like enter value of alcohol, right? And we have to give the range. So let's just write this as a range. And the range is some sort of like this. Inside the round brackets, you can just give the range is like the minimum value. Okay. And then the maximum value. Again, write the same curly braces, and you can just give the maximum values like this one. Okay. There might be chances the value length could be so we can simply make a round of this value, right? You can just simply keep it the round of 2, so that user can easily give the value, right? Let's just use the round function. Now we have created this input function where user will simply give the input, and each input will be stored inside the answer, right? Now what we will do with this answer? So you can just call this as user, and whatever the answer that we are getting, just simply append all the answer inside the user. Once we append all the answer inside the user, this will become the test data set where we want to predict the value. Because we have already the model, so we can just call the model and we will predict the value, right? And if you want to predict the value, now you have to give the data set in a 2D format or like the 2-dimensional format. So we are using the list where it will give the value, and you know that we will get the 3 different values, or like 0, 1, and 2. Okay. So we have to slice out all those values, and let me just store this inside the prediction. Okay, whatever the prediction that I am getting is like stored inside the prediction. And we know that we have 3 different qualities now. So let me just write this as QULITIS. Qualities is equals to low. Second is like the medium. And the third one is like the high quality of wine. If we are getting final output answer as 0, so it is like the low quality of wine. If the answer is 1, so it is like medium quality of wine, and then the last one is the high quality of wine, right? So whatever the answer we are getting, you can just simply write down this thing. Okay. Predicted wine quality is, just call this F, and you can just simply subscript the value, go to these qualities, and we know that the prediction answer either will be 0, 1, or 2, right? So you can just subscript the value, or you are just slicing the value, right? It's like go to this predicted wine quality, use the qualities value, and then it will give you the 0, 1, and 2, and based on low, median, and high. Whatever the word that we are getting, you just have to simply write this as a low quality, right? If we are getting low answer here, so we'll get the predicted wine quality is low quality, or like medium quality, or like the high quality. Okay, so let me just run this function. Okay, now call this function. The function name is predict wine quality now. So let me just call this function. And okay, and it will ask you for the value now. Enter the value of alcohol range, and that is the reason we have created this. Like minimum range is this, and the maximum is something like this. Okay. Okay. The problem with this one now, let me just stop this first, because whatever value that I'll give, it should be in the numerical one. So let me just convert this into the float, right? Otherwise, it won't work, right? Now run this again. The alcohol range is some sort of like this. Let me just pass this 15, right? Okay. X has one feature, but okay. Now the problem is this, like we have predicted the model inside the for loop. You have to keep it outside the for loop, right? Now run this for loop, run this function again. Let's just pass the value of alcohol as like 15. The malic acid range is some sort of like this 4. The ash range is something 3. The alkalinity is some sort of like this 25. Magnesium is some sort of, let me just cross the value, is like 180. Total phenyl is like 4, and the flavonoids is something like this 5, and the phenyls is values like 0.55, and procathinines some sort of like this 3, and color intensity is like 12, and hue range is some sort of like this 1, and the diluted value is like the 3, and the final one proline value is like 1500, and candidate we are getting the predicted wine quality as the low quality. Now you can run this function. You have to give the all features, and then it will give you the wine quality. Either it can be low, medium, or high. So in this way, you can build the model based on the random forest. And we have created the model as well and the prediction function as well, where we have to simply pass the values, and it will finally give you the classification of that wine, the low quality, medium quality, or like the high quality. So that is all about for the today. I hope everyone is getting my point, guys, right? Is there any doubts or question related to any of these? I think this is good to go, right? So now we'll connect tomorrow and we'll start with the boosting part, right? We have already completed with the bagging one. The bagging one is all about to create the bags or like the bootstrap aggregation of multiple model, and the random forest is the example of this one, right? Where we are creating the bags or like the bootstrap aggregation of decision trees model, right? And for the interview point of view, this one is very important. Okay, so let me just share this notebook link with all of you so that you can take a reference of this. Okay, and I'll upload the same notebook over the GitHub link as well. And don't forget to complete this project, right? I have given you 2 different tasks. The first project is about to create ML model that predict the fuel efficiency. This is the link. And the second model that predict the heart disease. And you have to use all the models, right? Not just only the single model. You have to build the multi-model approach, right? Let me just share this link. Okay. So in case of any issue, you can just let me know tomorrow, and I wish you the best. So guys, is there any doubt or shall I close this session? I think this is enough for today, right? Anyone just kindly confirm in the message area. Candidates, take a reference from the recording and take a like reference from the notebook as well, whatever they shared with you, right? And just try to create the model based on that, right? Okay, just stop the recording.